OTV stands for Overlay Transport Virtualization. The reason why it is called as Overlay Transport Virtualization is it sends layer 2 traffic encapsulating. Layer 2 traffic is encapsulated over layer 3 routing. Layer 2 is encapsulated with layer 3 and sent. So it depends on underlying IP path. And why it's transport? It can transport via any sort of media. You may have Ethernet or fast Ethernet or any layer 2 standard, any physical cable, any type of physical media that you may have, serial or WAN or LAN, whatever. WAN, whatever the type, any sort of transportation. MPLS in the cloud, never mind, still it will work. So it gives you a virtual circuit. It establishes a virtual circuit between two data center. Let's say we got data center 1 here and data center 2 here, and this is in Mississippi, and this is in Pune. Two different geographical location, two data centers. They're going to be bridged. And there is an internet cloud in between. And these two data centers are going to communicate as if they are in a same LAN, same layer 2 domain. They're going to communicate as if they are in a same location, same local area network. Why we do that? When we have multiple networks, it's time consuming. Each router in the path has to find the route and send the packet. Many number of hops are coming into picture. So we can avoid that when we bridge. That bridging is possible through overlay transport virtualization. What overlay transport virtualization does is it helps to bridge between data center. It helps to have a OTV tunnel, a kind of tunnel between these two. So inside the tunnel, this tunnel is established using layer 3. I take layer 2 frame, I encapsulate with layer 3, I deliver to this destination. This is decapsulated here and taken as a layer 2. This is possible with the help of a special switch called Nexus. Let's say I got some Nexus 5K, 5500, 25500. Let's say I have 25500. Why I'm going for 25500? For redundancy. So we got a big LAN here, LAN 1 in data center, LAN and SAN, 1 in data center 1 and data center 2, LAN and SAN, LAN and SAN. So I want to bridge between these two data center. I have a special switch called Nexus switch. Let's say it is 5500 switches. Now this is connected to a normal classical Ethernet network, and let's say this is a trunk port where, because I have multiple VLANs, VLAN 10, VLAN 20, VLAN 30, VLAN 40, and so I configure trunk here. So these two interfaces are trunk interfaces, and this interface is connected to the WAN. So this Nexus box has got one connection with my internal network, one to the external. So this interface, I call it as internal interface, internal. And this interface we call it as member interface. Not exactly. Wait a minute. This is called as, let me quickly pick up the word. Okay, this interface is called as join interface, not member, join interface. The physical interface, the WAN, the interface that connects to the WAN, it's called as join interface. And this is called internal interface, the one that talks to the LAN, the classical Ethernet wire. Now this is called as join interface. The reason is, on this Nexus box we will have a special type of interface called overlay interface. Like SVI, we create a special interface called overlay interface. We created this. We create an overlay interface. The command goes like this: interface overlay 1. And to this interface we'll make this physical interface as a member. Let's say this physical interface name is Ethernet 1/25. So Ethernet 1/25 we make as a member of overlay. We join this interface Ethernet 1/25 to carry all the encapsulation on this link. So this link will be the physical link, the black color wire. The black color line talks about the physical link, and the blue thick wire talks about the OTV. Now what OTV does is it takes the layer 2 frame and encapsulates with layer 3. When it encapsulates with layer 3, what will be the layer 3 source address? It will be this interface address, Ethernet 1/25's address. What will be the destination address? It will be this interface address on the DC2. It sends there. Encapsulates with layer 3 IP address and sends. Now the packet moves to that other end, and in the other end it decapsulates and finds the MAC address and delivers the packet to that particular destination. Now, what if I want to send only VLAN 10 and 20? You can say overlay OTV, allow only VLAN 10 and 20. Now, VLANs are allowed on OTV by extension, by extending. By default, no VLAN traffic goes inside unless you extend it. Here we got 4 VLANs. If you want all these 4 VLANs to talk to the other side, VLAN 10, VLAN 20 and VLAN 30 and VLAN 40, you need to extend it over OTV by giving the command extend. So all those configuration goes under interface overlay. So when I do so, OTV comes up. Now OTV also uses ISIS protocol to learn the update, to send the update, to discover the neighbor. Intermediate system to intermediate system protocol is what used. Now this ISIS uses 2 different methods to discover neighbor. One, by sending hellos to the multicast address, a common multicast address between these two. We configure, let's say I say 223.224.1.1.1 assume. Here also I'm saying 224.239.9.1.1.1. Because these two have same multicast address, they can form neighbor. So ISIS uses multicast address that we define. If you say no, I don't want to use multicast, they are not connection oriented, they use UDP, not secure. There is another option where you can have a common server to which we go and register and do unicast instead of multicasting. That's another option. Another thing, if in case I want to use multicasting, I want to use multicast address and discover the neighbor, I want in a secure manner. OTV supports two type of authentication: clear text as well as MD5 authentication. So you enable authentication under this overlay interface, give same keychain on both the side. That gives you more reliability. Now here we see that we have two switches, two OTV switches. Now if I have two OTV switch, the updates from this LAN will be sent. If it is sent via both the switches, then there will be a duplication on the other side. To avoid that, there will be one switch elected between this switch. There will be one switch elected as the authoritative edge router, edge device, authoritative edge device. These two are edge device. In that one, among this one will be elected as the authoritative edge device. And that is the only device which will be sending and receiving updates, sending unicast or multicast. All the stuff will be done by only one box. And whatever this learns will be given to the other box for synchronization. There will be a link. You can have one or two links bundled. Make sure you put these links in a dedicated VLAN only for this purpose. It is recommended to dedicate a VLAN for this synchronization link, the link that synchronizes between these two devices. A kind of peer link. It's not exactly peer link, a kind of peer link. The command goes like this. Let me parallelly show you. Now here we go. See, a dedicated VLAN is been allocated, is been given for the synchronization between the edge device, OTV site VLAN. It is called a site VLAN. Site VLAN. You create VLAN 200 as site VLAN and you make these two interfaces a member of 200 on both the switch. It's not really recommended to use that same 200 for some other traffic as well. Do not use it. Now when I do that, what happens is, it works same like peer link. No traffic will pass through this except the synchronization traffic. To have fast synchronization, we go for multiple links, bundling them and having an ether channel there. So they send periodically updates. This once they form neighbor by sending hello, they send all the MAC information from this side to that side and that side to this side periodically. Now let's say there is a PC here called A and wants to talk to B, which is in the same LAN. It goes here and the switch finds that the destination is in the internal network. It is internal, so it sends like that. It won't send via OTV. Not necessary. It won't send. In case if it wants to talk to someone here, D, A wants to talk to D, the frame comes here and this checks the destination. Destination is on the remote. So how it will look like? It will look like this. Table will look like this. D is where? D is on 10.0.0.2. 10.0.0.2. So now what it will do, it will use OTV. It encrypts this layer 2 frame with the help of layer 3 address and it sends to 10.0.0.2. Packet goes there and this decapsulates it and it looks the destination MAC address and delivers the packet to D. So this is how OTV works. Any doubt? So OTV to bridge the data center. Traditionally, we were having data center bridging, but it was not so friendly. When one data center connection between one data center goes down, all the data center will go down. So there are a lot of problems we were facing because of Ethernet over MPLS, virtual private LAN services. This is also a layer 2 VPN or dark fiber. These are all were there before our OTV. Whatever the OTV does for us now, these technologies were doing for us, but with some limitations. Those limitations are no more in OTV. OTV stands for overlay transportation. Overlay transport virtualization, which is nothing but MAC in IP address. MAC in IP. Layer 2 in layer 3. Layer 2 frames are encapsulated with layer 3 and sent over the virtualized tunnel. So the benefits, there is no pseudo wire needed. We don't create an interface tunnel or a virtual interface. It is just called as overlay. It is not a pseudo wire kind of approach. This is different, and there is less use of multicasting. And then it supports multi-point connection, meaning you can have multiple data centers interconnected using cloud. So we can also call it as point to cloud model. And this has got an inbuilt loop prevention mechanism. So if one of the data center goes down, the other sites are, because they are independent, they are not going to be disturbed. And if there is multiple edge device, you can form neighbor with multiple edge device called multi-homing. Right. So next is, we don't believe this term, not available at Nexus 7000. This is a confusing statement here. In exam, we do OTV on 7000 series. We'll talk about that when we do that tomorrow. It needs a license, that's it. It needs a special license. Now, OTV components, we have edge device. So these two switches are edge device. And we got internal interface. This interface or internal interface, which is local to the LAN. And then we got join interface. Join interface is the interface that connects to the cloud. We got overlay interface. Overlay interface is the interface that we create called interface overlay, which encapsulates the layer 2 frame into IP packets. Now the forwarding takes place in two different ways, as we already discussed. If the destination is in the same LAN, it will not use OTV. It reaches through the other internal interface. If the destination is in remote, then it uses overlay transport virtualization. Now when it uses OTV, the VLAN numbers are copied to OTV. See, it is OTV shim. So when you extend the VLAN and the type of service, all those things are copied. And see, IP header, the encapsulation happens for the ether frame and sent. Now this is how the data plane forwarding will look like. You see, for Mac A and Mac 1 and Mac 2, for Mac 1 and Mac 2 in the table, they belong to VLAN 100. They are local to this OTV. So you see that interface name Ethernet 2 and Ethernet 1. So any traffic from Mac 1 and Mac 2 will not use OTV. But if the traffic wants to go to Mac 3, which is also in same VLAN but in remote, it has the IP address of B. So This B is the one which is selected in between these two devices. There are two devices. One is selected as authoritative edge device. So that address only will be learned on the remote device. To that address only the traffic will be sent. So B's address you see for 3 and 4. Whenever traffic wants to go to 3 and 4, see it encapsulates like this. Your internal layer 2 is encapsulated using layer 3. Only by seeing layer 3 packets are forwarded here. These MAC addresses are preserved. See, if I don't have, what happens is this original MAC address will not be seen on the destination. Here the original MAC address of source and destination is preserved here in OTV. So that gives a feeling of local network, though they are not local. These MAC 1, MAC 2, MAC 3, MAC 4 feels that they are in a same local area network where you don't have multiple broadcast domains. You break the barrier there. So it is a protocol called ISIS that is working behind in the background to advertise the MAC addresses between data centers. They send the MAC address periodically and update. Now, to discover neighbor, what neighbor? OTV neighbor between these two sites. Before they share anything, they should form neighbor and establish OTV. To discover neighbor, there are two methods, as I already told you. One is by using multicast address, another one is by using the adjacency server. Using multicast address is what we see in exam. You can also use an adjacency server to which all the OTV edge device will go and register. It's like a rendezvous point in multicast, sparse mode, a reference point. So that's the common server where the edge device go and register. The simple solution is using multicast. Now this uses multicast, an advanced level of multicast source based, like it uses IGMP version 3 for multicasting, which is more secure. So that's what here it is explained. If you are using multicast address, you use IGMP, you send hello messages to the multicast address and discover neighbor. If you don't want to do multicasting, if you want to do unicasting, it is supported from Nexus OS 5.2 1 version onwards, where you can do unicast. How? By creating one adjacency server and going and registering with that adjacency server. By doing so, you can do unicast to the remote OTV destinations. Now about the STP. Now here I got STP running to prevent loop. Here also I got STP. Now are they same? No. The STP is local to the LAN. Though you are forming LAN between this remote device, the STP is not going to be between these two different data center. STP scope is only within this internal LAN, only on the internal interface. The BPDs are not sent over OTV. So no BPDs are sent over OTV. Now, when you want to use same VLAN for OTV as well as for SVI, you can do it only if it is two physical device or two logical device. You create two VDC. Let's say you want to have VLAN 200 on OTV. You also want to have interface VLAN 200, which is SVI. That is not possible. That's not recommended in a single device. So if you have two Nexus device, On one device, VLAN 200 you use for OTV. On the other device, you use for interface SVI, interface virtual, switch virtual interface. No problem. Or you logically divide that 7000 box into two. See, 7000 supports VDC.
But what will be the impact of that if we use the same VLAN for
Very
both
good
of them?
question. See, what does SVI do? Switch virtual interface does what? That is not doing any encapsulation. Meaning, they don't take layer 2 and encapsulate it with layer 3. But OTV does encapsulation. So they are two different nature. How can I have the same VLAN traffic? One says I'll simply send without any encapsulation as just a normal routing. The other says no, I'll take and encapsulate it. The two on the same device. One says this VLAN 200 is extended over OTV. The other says I don't mind, I don't understand what is OTV. I'll send like this. So that will be a conflict. So it is recommended to keep it separate. If you want to have same VLAN 200 for SVI and for OTV, then do it on two different devices or two different VDCs, two different virtual device on same device, on same physical device.
One more question.
Yes.
Uh, let's take an example where with this OTV, we are extending our VLAN from one side to the other side. In that case, the OTV VLAN that will be also extended.
No. See, that is very important. I think there is no VLAN called OTV VLAN. There is a VLAN called site VLAN. That will not be extended. Site VLAN is only for synchronization between these two boxes, edge device.
So it's local.
Yeah, it is local. It is local.
Okay.
So here it talks about multi-homing. When you have multiple edge device, only one will be authoritative edge device, which is responsible for all sort of advertisements, forwarding traffic, learning MAC addresses, and so on. By doing so, it avoids unnecessary duplication of packets when it sends or when it receives the update. Now, configuration is very simple. 4 steps. First of all, we need to join OTV. We need to configure the join interface. What is join interface? The physical interface. This one, this black line that connects to the OTV cloud. So this has to be configured with an IP address like this. Interface Ethernet 1/25 and give an IP address, and you join the IGMP version 3. Only this much. We must give an IP address. That is done. One small command you add. What is that? IP IGMP version 3. That's it. Now one step is over. The other 3 steps. Configure internal interface. This is not new for us. What is internal interface? These interfaces. With normal configuration, there is no new configuration. You go and say interface as switch port. If you want it as a trunk, you make it as a trunk. If you want to leave it as an access, you leave it as an access. If you want to have a trunk and you say I want to allow only these VLANs, allow this VLAN where? Not over OTV. I'm allowing on this interface, these VLANs. Allowing over OTV configuration is different.
IGMP version 3, this is required, compulsory.
Yeah, it is must. It is must.
Hmm.
Now, we say configuration, internal configuration, it can be anything. Any VLANs can be allowed. Next is third step. Enable OTV and configure site VLANs. Enable OTV and configure site VLAN. What is site VLAN? The VLAN that is dedicated for synchronization between two edge devices. So let's see how to do it. Feature OTV that enables OTV. OTV site VLAN 200, which means it dedicates VLAN number 200 for OTV alone, means no edge device synchronization. And then OTV site identifier, give any number, and this number should be same on the other peer in the local site. In this site, if you have 2 device or 3 device or 4 device on the edge, all the devices need to work together and only one authoritative edge device need to be selected. For that, the other devices should know how many redundant devices are there in the local site. So we give a site identifier so that these devices will know how many standby devices are there. That's for grouping. So one will be selected. If I have 2 devices with same 256 identifier, one has to be selected as authoritative edge device. Now this is the last step. Fourth step is configure overlay interface, where something new you are going to see. We create an interface called interface overlay. Give any number. Give any multicast address. In exam, whatever they say, or if they have already configured, make sure both the side it is same IP address. And then if you want to, this is also very important, the subnet of this multicast group plus extend VLAN. When I say this, all traffic from the internal interface, when it wants to go to the remote, only the traffic that is coming from 100 to 199 and which has destination in the remote will be allowed to use this OTV. If I didn't say this extended VLAN, then not allowed. Next is, you see, join, OTV join interface, Ethernet 1/25, which is this one. That's why we call this as join interface. It joins to overlay, or overlay joins with this and sends the traffic. And you say no shutdown at last. Now, if you want to have more security between the data center, if you want to check before forming neighbor, then you can enable authentication like this. Go under that same interface overlay one which we created in the previous slide and say OTV ISIS authentication check. I want to enable MD5. You also have clear text, and I want to use this keychain. Do that same thing on the other side with the same key. That brings the neighbor up if multicasting IGMP version 3 with same multicast address is given. Now this is the other one option. If you don't want to use multicast, if you want to do unicast, all that you need to do is you need to define a server, a common server, and that server should be reachable from the other side. And I need to say send the update to this one and try to form neighbor. And once the neighbor is established, they will send update. This is the command to do that. This is statically defining. See the difference between static route and dynamic route, same story. There you use multicast and neighbors, the remote site is dynamically learned. Here you use static. Now when we have HSRP is local. HSRP traffics are not passed through OTV. So this HSRP is local and this HSRP is local. Same like BPDU. Not necessary now. Alright, that's all about OTV. OTV with HSRP we'll see in a different case. So overall OTV is done. The special cases, exceptional things, all the stuff we'll see some other day. Tomorrow we are going to do hands-on. What all we are going to see is OTV, fabric path, VPC, VPC plus. These are the things that is there in section 1 in our exam. Those things we are going to see. I would recommend you to go through the question and the solution once and come, so that it will be easy
Can
for
you
you
share
to
the
understand.
topology of tomorrow's lab?
Yep, I'm doing that.